All right, so I noticed recently I say that in the beginning of every of these live sessions. I guess that's my catchphrase. All right, so I'm going to be talking about solving rational inequalities by graphing. So I do have a video going over the algebra, and it does have a little bit of the graphing, but I thought it might be worth focusing more on the graphing because that might help you understand more what's going on. And then that also is a second way to double check your answers or to solve these if you're like struggling on a quiz and you just don't have time to, necessarily do the work or something. So first, what is a rational inequality? So if we just break it down, the word inequality means that we've got the less than or greater than symbols, or you could have a not equal to, but we usually just have less than or greater than stuff. And rational means that there's a rational expression in it, which means that we've got a fraction going on with variables in the denominator. So in order to solve rational inequalities, we want to have the right side of the inequality be 0. And this is the same rule that we had when we solved polynomial inequalities. So that's just consistent for solving these types of things. And we have 4 forms basically because there's 4 different inequality symbols. And the key is that you've got to have 0 on the right side in order to do the comparisons either by solving or by doing the graphing. I don't know if that was heard on the recording, but I just heard a really loud noise happen underneath me, which was very disturbing. I don't know what just went on. I guess I'll keep going and find out when this is over. Fun. Okay, so what does this mean graphically? So we have a rational function, and we can think of it as p over q because we've got a fraction. Usually this will be written as f of x because it's a function, or think of it as y. So we're really looking at the y values here when we have these inequalities. So whenever you see like your function less than 0, think of where is the y less than 0. So for the less than, we're asking where is our graph or function below the x-axis because that's where we have negative y values. And with the less than, we don't include the x-intercepts because that's where it's equal to 0, and equal to is not included with the less than symbol. And when we give our answer, it's always what x values, over what x values is our y below. So you figure out where is my y underneath, and then what are the x values for that section. That's basically what this is. Less than or equal to 0 means you do include those x-intercepts because you can be equal to 0. Then we've got greater than and greater than or equal to, and those are both where is it above 0, which means where is our y positive, so we're above the x-axis. And then whether it includes the intercepts or not depends on if it's a greater than or equal to symbol. So when we're looking at these graphically, we're just thinking where is it above or below the x-axis, and then you're just determining are those zeros, those intercepts included. So let's take a look at this example here. We don't know what the equation is, we just have the graph. And we're going to just break it apart into all of our 4 possibilities. Where are we less than 0? Where are we less than or equal to 0? Where are we greater than 0? Where are we greater than or equal to 0? So this is, of course, a rational function. You've learned about these last week when we were graphing rational functions. And we've got 2 asymptotes here. It looks like our vertical asymptote is at -3, so that's really important to note. So I'm going to just write that down. So that is at x equals -3. And then it looks like we've got a horizontal asymptote at y equals 0. So I'm going to just write those in because those are important when you're determining where your intervals are because we can't cross these basically. So f of x less than 0, this is where is our y values, where is our graph below the x-axis. So our x-axis is right here. I'm not very good at drawing straight lines, but it's right there. And our graph does not go below there. So that means there's no solution. There is no section where we're below the x-axis. So it's the empty set symbol, or we can write it with like literal empty set with nothing in there, but there is no point where we're less than that. Less than or equal to, that would include any x-intercepts, but we don't have any x-intercepts because we have a horizontal asymptote, which means that we don't touch the x-axis. So again, no solution here. Now, greater than 0. Well, the entire graph is greater than 0, but we do have that gap at that vertical asymptote. So we have to indicate that when we give our domain. So I like to think of this, and I'm going to erase what I have for my what I drew when I drew in the horizontal, and I like to kind of highlight. So we're basically covering everything here and everything here because that's the values that we're above 0, and then there's a gap at the intersection or where the horizontal. The vertical asymptote is. So if we think of this, let me draw this as an easier number line. And our vertical asymptote, we don't have a number, so you can think of it as an open circle. And then we are above our x-axis in either direction there. Because our graph, the blue part, is above our horizontal line. So when we write this as interval notation, we've got negative infinity on the left to -3. And -3 is not included because it's a vertical asymptote. Union -3 to infinity. I'm kind of running out of room there. We can't include vertical asymptotes because those are not part of the graph. And now for the last one, greater than or equal to 0. So that would include any x-intercepts if we had any x-intercepts, but we don't have any. So it's going to be the same answer as the one above. Negative infinity to -3, union -3 to infinity. Okay, so let's take a look at this example right here. Same sort of thing, we've got a graph and we're going to just kind of look at where is it less than, where is it less than or equal to, where is it greater than, where is it greater than or equal to. And this graph is a little more interesting. So we've got a vertical asymptote here, and that looks like it's not, oh, they tell us x equals 3. So they're very nice. They have that pointed out on the graph that said x equals 3. And then we basically have a slant asymptote going on, so we don't have a horizontal asymptote. We have a slant asymptote. So our first question is, where is our function less than 0? Where are the y values less than 0? So if I highlight here, there's this section here that we're less than 0. And then there's this section here where our whole graph is less than 0. So, I mean, I can separate it out here, but those are basically the two parts of our graph where we are less than 0. We're below the x-axis. So let's translate this into a number line. Actually, I'm going to do the number line underneath so that I have a little more room. I've got negative infinity to positive infinity. Now our graph starts going above as soon as we head to 0. So we've got one of our x-intercepts labeled at -6, and then another one is at 1. So I should actually clarify my picture a little bit, because it's not that whole triangle area, it's only this part right here where we are less than. Because as soon as you hit that other x-intercept, it starts going above the graph. So from -6 to 1, we are negative. So I'm going to kind of highlight that part. And we're less than 0, which means the zeros or the x-intercepts are not included. So they're open circles or parentheses here. And then we don't start getting negative again until we've kind of hit the vertical asymptote. So we're positive until we get to that vertical asymptote, and then we switch to negative. So the vertical asymptote is at 3. We can't touch a vertical asymptote, so that's always going to be a parenthesis. And then we're negative everything after that. So our y-values are negative everywhere after that. So we've got 2 sections here. We've got our section from -6 to 1, where our graph is below 0. And then since we have to connect it to a second section, we have to use the u. Then we have 3 to infinity, where our graph is below 0, where it's got negative y values. Now let's look at the less than or equal to part. The only difference between these two is that zeros are included. So any spot that you have a 0 or your x-intercept, it turns into a bracket. So we have x-intercepts at -6 and at 1. So both of those turn into brackets. But the vertical asymptote stays as parentheses because we still can't touch a vertical asymptote. So now let's look at greater than 0. So I'm going to erase what I've got on my picture here. And greater than 0 means above the x-axis. So we've got this section here where our graph is above. So I can highlight it, because our graph is going up here. It's above the x-axis. And then we're above this little part right here. But that's it. Everything else is below. So if we put this in number line form, I've got -infinity to infinity. I've still got all the same numbers. I have my zeros and I have my vertical asymptote. So those numbers don't change at all. Now I am above when I'm to the left of -6. But we're greater than 0, so we don't include those zeros. We're not including the x-intercept, so that's going to be a parenthesis. And then I get above again between 1 and 3. And once I hit that vertical asymptote, then we start going negative again. So you can see that it's actually sort of the opposite of it's not really, it's like a negative. If with photograph negatives, you've got sort of the inverse going on. So our picture or our number line where I'm graphing the parts that are above is like the inverse of what's below. It's the negative of the other part. So when we translate this into interval notation, we have -infinity to -6, union 1 to 3. And we're using all parentheses because we're not including any of the zeros. Then the difference is when we've got greater than or equal to 0, now any 0 becomes a bracket because we can include those 0 points. So -infinity still has a parenthesis, but now -6 becomes a bracket. We have our union, and then 1 becomes a bracket because that's a 0, but 3 is the vertical asymptote, so that still has parentheses. So the numbers that we use are all basically the same. Which symbols you use depends on the inequality, and then which parts of the numbers you're using, which parts of that number line you're using depends on the inequality. And that comes from reading the graph and thinking, what is above my x-axis? What is below? So here's one. We're going to solve the inequality by graphing. And so in order to do this, we need to determine where are the x-intercepts, where are the horizontal and vertical asymptotes, and then we can get a graph, and then we can solve it. So let's go through all that, and I'm going to just kind of make a graph here as best I can. So our vertical asymptote is where the denominator is equal to 0. our denominator is at x, so it's x equals 0. So literally the y-axis is my vertical asymptote. So I'm just going to put some dashes there. For our horizontal asymptote, our degree of the top is equal to the degree of the bottom, because we have a linear on top and a linear on the bottom. So that's going to be at the coefficients for the x's, 4 over 1. So that's going to be at 4. So I'm just going to put 4 on my graph. Now we want to look for any x-intercepts or any y-intercepts. So x-intercepts are where the top of the fraction is equal to 0. So, 4x minus 1 equals 0, so we solve. So I'm going to add 1 to both sides. 4x equals 1. Divide both sides by 4. We get x equals 1/4. So I'm going to, we'll put it right about there. I'm just kind of eyeballing it. It's just a sketch here. And then the y-intercept is where x is equal to 0. Now notice all of these I'm only doing on the rational 0 part. I'm just ignoring the right side. I'm only doing it on the fraction. Now notice no y-intercept because dividing by 0 is undefined, and that's because it's a vertical asymptote. So we don't actually cross our graph here. So if I had to hazard a guess, I would think that this part kind of looks like how I've sketched it here on the right part. And then the left side, we need to determine, okay, are we going to be above or below our vertical or our horizontal axis? So you can plug in a number like -1. So 4 times -1 minus 1 over -1. So that's -4 minus 1 over -1. That's -5 over -1. We get 5. So like we're going to be like up here. So I'm going to say, so this graph is going to roughly look like this. So what I've done here is just take the techniques that I talked about last week with the rational function, finding the asymptotes, finding the intercepts, and kind of, those are the parts of the graph that are important. And I use that to sketch a graph. But what's really important here is the x-intercepts and the vertical asymptotes. That's what's important when we're solving these inequalities. So I'm going to actually bring up Desmos to verify and to show you, how you can do this in Desmos. So I've got Desmos up here, and I'm just going to click Graphing Calculator. And when you put this in Desmos, you only want the rational function part. You don't need the inequality or anything else. So I'm just make it y equals. And then I'm going to type in my fraction. We've got 4x minus 1 over x. And so you can see that this actually does match what I had basically, what I had sketched by hand. So what's nice about doing it this way is that they do give you those 0 points. So you can see that the x-intercept is 0.25. And then you can see that we do have a vertical asymptote at 0. And so now our question is, if we go back to what I've got here, we want to know, where are we greater than 0? Where are we above the x-axis? And we're including zeros because it's greater than or equal to. So looking at my sketch here, everywhere to the right of our x-intercept, our graph is above this x-axis. And it's above on this part to the left of the vertical asymptote, because it's above that x-axis. So there's a little tiny section where it's not above. So to solve this, we can translate this into a number line, which is how I do all of these types of problems, especially when you're dealing with things that are like inequalities and having to do domain and that kind of stuff. So you always put your vertical asymptote on your graph, and you put any x-intercepts or zeros, so that's at 1/4. And so we're including the zeros because it's equal to, so I can use a bracket here. And then we're shading everything to the right. We cannot include vertical asymptotes because you can't have that value, so that's always a parenthesis. And then we're above everything to the left. So this gives you your answer, basically. We have -infinity to 0, and then we have a gap, so we have a union, and then a bracket at 1/4 to infinity. And that is where this rational inequality is greater than or equal to 0. So I graphed what we had on the left, and then I looked, where is it above my x-axis? And that's how we get our answer here. Here we've got x² - 1 over x. So this is going to be something that's going to have a slant asymptote. And it's over x, so we still are going to have that vertical asymptote be at 0. We're actually going to end up with 2 x-intercepts here because the top can be factored. We're going to get plus and minus 1. So I'm going to just sketch the graph here. Now, you guys don't have to really be able to sketch these graphs by hand like I do. You can just use Desmos, but I like to do this so that you can see it on your paper. So we've got our vertical asymptote at x = 0, and I know that we're going to have intercepts at -1 and 1. Oops. And then I'm going to have a slant asymptote. Let's see if I can do this quickly. That's going to be at y = x. So I'm just kind of eyeballing it. So I'm going to have a slant asymptote. And I think what's going to happen is the graph's going to look something like this. I didn't quite go all the way through my x-intercepts, but I tried. So what I'm going to put in Desmos, and when you're doing this by graphing, what you are going to be putting in Desmos, again, this left part, the rational function part. So I'm going to bring up Desmos again. And just turn off this graph. Y = and we've got x², oops, I wrote y - 1 equals x² - 1 over x. Okay, so that looks roughly like what my graph looks like. So let's go back to the problem. Now that you verified that our sketch is correct, we want the parts that are less than 0 because it's got less than 0 there. So we want the parts below the x-axis. So if I look at this here, we're looking for this section here. We're below. So we're below between 0 and 1 basically here. Then we're above, and then we're below again. So we've got 2 sections here. We've got this section to the left of -1, and then we've got a section from 0 to 1, because that's where our graph is below. So bringing up this PowerPoint here, we are below in this little section. That's where we're underneath. And then again, here. So if I translate that to our number line, I put my zeros. You always put your horizontal asymptote on there, and you put your zeros on there. We are below to the left of -1 because we're less than 0, so our graph is below to the left there. And it's less than, which means that we are not including the zeros. So since that's a 0 and it's not included, we're going to use a parenthesis. Then we have a gap, and then we're below between 0 and 1. We never include vertical asymptotes, so that's going to be a parenthesis. And then because this is less than, we're not including the other 0, so that's going to be 1. So this comes to negative infinity to -1 union 0 to 1. So that is our inequality solved by graphing. All right, so here now this is going to be an interesting one. I know we're going to have, our horizontal asymptote at 3. But one thing that you may not notice immediately, is that notice that it is not 0 here on the right. So it has to be 0. So what we need to do is rewrite this so that we have 0. So we want to rewrite this by subtracting 1 from both sides. Now, when we're solving by graphing, that won't matter too much. We can still put this in Desmos, and actually, because of that -1, our horizontal asymptote is probably going to be at 2. So let me just kind of put in my graph here. I don't think we're going to have any vertical asymptotes, and then we're probably going to have a horizontal at 1. But let me put this in Desmos. So y equals, we have 3x squared over x squared plus 4, and then -1. Okay. Yeah, so our horizontal asymptote is now at 2 instead of 3, and we have no vertical asymptote. So this is what it looks like. And we do have 2 x-intercepts here. So, okay. So we're going to be approximating these. These are actually, I believe this is plus or minus the square root of 2. Yes, because, let me double check. Square root of 2. Yeah, so these are at plus or minus the square root of 2. So when I'm going to attempt to draw my picture here. We have the square root of 2 and negative square root of 2. And then we have a horizontal asymptote at y equals 2. And we did have a y-intercept. Where's our y-intercept? -1. So our graph is looking something like this. Okay, so now that I've got my picture, we're looking for where this is less than 0, because we subtracted 1, so we're now less than 0. So we are below the x-axis in this section right here, in between those 2 x-intercepts. So if I was to put this on a number line, we have a negative square root of 2 and the square root of 2. And it's a less than, so we're not including those x-intercepts. So there's 0, so those are not included. And so we are in between those. And so it's negative square root of 2 with parenthesis, 2 square root of 2 with parenthesis. Now, this is an example of one that if you try to do something like this in Desmos, or not Desmos, in ALEKS by graphing only, if you don't know what the square root of 2 is, and most people don't, you would be looking at the decimal approximation, so your answer is not going to be exact. And we usually want exact answers. So if you are solving it by graphing and you get decimals, that's an indication that you need to go ahead and do it with algebra, the method that's in my other video, so that you can get those exact answers. Unless you happen to know what the decimal approximates to, you're likely to not get the exact answer because of rounding, and it's going to cause issues with Alex. So a problem like this that I just did, this is one that you'd want to solve with algebra because otherwise you get decimal approximations. So that is why you learn the other method, because you can't get exact values this way unless you just happen to know what the square root of 2 is. So I've got one more example here. So this one, I'm not even, just like the other one, I'm not even going to attempt to try to graph this one by hand. I've got a lot of stuff going in here. It's something that's going to be x to the 5th on top over x squared. We're going to get a slant asymptote. So we're going to just graph this in Desmos. So y equals, and I get my fraction. So this is a complicated one. I got 3 minus x, and that's going to be one of my x-intercepts is going to be at 3. Then we have 4x minus 1 to the 4th. So we're going to get another x-intercept at 1/4 from that one. And then in the denominator, we have x plus 2 squared. So there's not going to be any vertical asymptotes because of the squared part. It's never going to be equal to 0. So, okay, so you see I'm zooming out and it's getting really small, but we don't really have a good view. So you're going to have to do some finagling here. This is one of the downsides of doing it in Desmos is you don't really get good pictures. So I have to hit the wrench here. So clearly I don't really need to go all the way to -10 here. I could probably even just go to -2 on the x. Oops. -2, and then maybe even 5 on the other side of the x. But so you can see we get a little bit better picture here, but we don't have what happens in between here. We're kind of, so I need to go up on my y. So let's say y goes to, I'm going to just do 100. Okay, so I'm still not figuring out getting the peak here, so we want to go higher than 100. Let's go 120. Nope. 150. Almost. Let's just do 200. Okay. So you can see this is basically what is going on here. It actually comes out to be a polynomial when you simplify it because there's no vertical asymptotes, but it is still considered a rational function because it is still in fraction form. So in order to figure out, we're looking at, if I go back to our problem here, we want to know where are we less than or equal to 0. So we're definitely below 0 once we hit 3 here and beyond. But what is happening in this section right here between 0 and, so like I said, this is going to be actually 1/4 here that we're going to, 1/4 is going to be somewhere here. So let me kind of look at what we have here. So we've just seen our picture and it's kind of distorted. So I'm just going to go straight to our number line. And we have 3 for sure on the number line. And we know for sure, actually, we know that we're below once we go past 3. 3 is a 0 or an x-intercept, and it's less than or equal to 0, so that's included. So I'm going to have a bracket there. Now let's go back to our graph. It looks like at 0, something else happens, but we don't really know. So now that we know, we need to know, are we ever below 0 as we zoom in here? So now I'm zooming in. Do we ever get below 0? It's really hard to tell. So I can click and drag, and you see that all of these are all positive. That's our x-intercept, 1/4, and then these are all positive again. So it doesn't look like we actually get negative below here at all. So we do have an x-intercept here, 1/4, but we don't actually get less than or equal to 0 there. So we get equal to 0, so I can put a little dot there, but we're not less than, and we're equal to 0, but we're not anything to either side of 1/4. because on either side of 1/4, we're above and we're looking for a less than what is below. So this is what our number line looks like. These are the parts of our graph that fit this inequality. And so there are multiple ways to kind of write this. You could use like a set notation for 1/4, just that single number, and then use interval notation for the actual part that's negative from 3 to infinity. If you want to get really weird, you can write this. Actually, that would be with brackets and just indicate, okay, it's just one single thing from 1/4 to 1/4. But we usually, if there's a single point, we'll write it in sort of set notation to indicate that that point is part of this. And then we've got this section that is from 3 to infinity that also fits this inequality. Now notice this is a weird kind of graph because we had to really zoom in here to kind of figure out, does this part ever go negative? It's hard to tell. You can't really tell, it doesn't look like it, but you don't know until you know what the numbers are. And we had to do a lot of finagling on the graph to kind of figure out what the graph even looked like, you know, what it's doing in between these things. So this is another situation where solving it by graphing is hard. And it would be better to solve this with our other method using algebra, because then you don't really have to worry about what's going on in this little section. The algebra will tell us. So solving by graphing is great for most of the simpler types of problems, but when you get to the more complicated ones, it doesn't work so well. And that's where you want to use these techniques that you're learning for solving the rational inequalities. So all of the equation ones that I did here are the same equations that I did in my solving rational inequality video, and that's where I'm showing how to do it by algebra. So I would recommend after watching this video that you go ahead and go to watch that video so that you can see, well, how do we do the algebra portion of this? And then you can check and say, oh, did we get the same answers? And if we didn't get the same answer, then I made a mistake somewhere, because we shouldn't be getting the same answers. And I haven't actually double checked to see if I get the same answers, but there should be the same answers. You should get the same versus graphing versus if you were solving it algebraically. So hopefully this was helpful. And if you have any questions, you know how to reach me, and I will talk to you later.